All right, welcome back. Let's keep making progress in this book, AI Engineering by Chip Huyen. So we're learning about K-top. K-top is a sampling strategy to reduce the computation workload without sacrificing too much of the model's response diversity. Recall that a softmax layer is used to compute the probability distribution over all possible values. Softmax requires two passes over all possible values, one to perform the exponential sum shown here, and one to perform another operation for each value. For a language model with a large vocabulary, this process is computationally expensive. And let me try something new during this video. I'm going to pull up ChatGPT Advanced Voice Mode and just keep it on. Hey, how are you doing today? Hello, are you there? Are you there? Hello?
Yes,
Okay,
I'm
so
here.
there seems
What's
to
on your
be
mind?
an issue with it right now.
I'm
So
here. Is there something specific you'd like to
yeah,
discuss or need help
it's
with?
not feeding, it's not using the right mic. So okay, I don't want to waste time with that then if it's not gonna if
No
it's not going
worries.
to do that
Sure.
correctly.
Just let me know what you'd like to talk about instead.
Okay, so that's fine. I'll just use it the way I've been using it before. To avoid this problem, the after the model has computed the logits, we pick the top k logits and perform softmax over these top k logits only. Depending on how diverse you want your application to be, k can be anywhere from 50 to 500, much smaller than a model's vocabulary size. The model then samples from these top values. A smaller k value makes the text more predictable, but less interesting, as the model is limited to a smaller set of likely words. Top-P. In top-K sampling, the number of values considered is fixed to k. However, this number should change depending on the situation. For example, given the prompt, "Do you like music?" answer with only yes or no. The number of values considered should be 2, yes or no. Given the prompt, "What's the meaning of life?" the number of values considered should be much higher. Okay, so you would use top K for a lot of fixed answers, but you would use top P for those broader answers like what is the meaning of life. Top P, also known as nucleus sampling, allows for a more dynamic selection of values to be sampled from. In top P sampling, the model sums the probabilities of the most likely next values in descending order and stops when the sum reaches P. Only the values within this cumulative probability are considered. Common values for top P nucleus sampling in large language models typically range from 0.9 to 0.95. A top P value of 0.9, for example, means that the model will consider the smallest set of values whose cumulative probability exceeds 90%. Let's say the probabilities of all tokens are as shown in figure 2-18. If top P is 90% and only yes and maybe will be considered, as their cumulative probability is greater than 90%. Okay, so if top P is 90%, only yes and maybe will be considered, as their cumulative probability is more than 90%. If top P is 99%, then yes, maybe, and no are considered. That's interesting. Let's see, the probabilities of, okay, so top P is 90%, only yes. I guess I don't understand what they mean by if top P is 90%. because I would yeah, I'm because we see in the diagram yes is 60%. So how does that 60% different than the 90% probability or the 90% figure for top P? So figure 2-18 shows example token probabilities. Okay, so these are token probabilities. Oh, is top P a token? Top P is a sampling. Ah, I wish I could have the AI working, but okay. So yeah, it says microphone in use here. It's in use for maybe that's what that means is because I'm using it for OBS, I can't use it there. So unfortunately, it's not going to work.
It sounds like the
And
microphone
we
is
can see
currently
it's
being accessed
responding
by
to me,
OBS.
but I just can't hear it.
Hi there. I just want to.
But what I can do is just use the other feature. That should be fine. And I'll do it in four. I'll use it in O1, and I guess 4.0 might be better. Um, oh, and I can't use advanced voice mode, but I can use this other mode. So briefly tell me the difference between 4.0 and O1. If I'm just reading a book and I want to have a little bit of a conversation about what I read, which model would be better to use for ChatGPT? ChatGPT. Sorry, there are typos, but the context should make it clear. I'm talking about ChatGPT. All right, so probably 4.0 because it's a lot faster. But in the meantime, let's continue. So unlike top K, top P doesn't necessarily reduce the softmax computation load. Its benefit is that because it focuses only on the set of most relevant values for each context, it allows outputs to be more contextually appropriate. In theory, there doesn't seem to be a lot of benefits to top P sampling. However, in practice, top P sampling has proven to work well, causing its popularity to rise. A related sampling strategy is min-p, where you set the minimum probability that a token must reach to be considered during sampling. Stopping condition. An autoregressive language model generates sequences of tokens by generating one token after another. A long output sequence takes more time, costs more compute, money, and can sometimes annoy users. We might want to set a condition for the model to stop the sequence. One easy method is to ask models to stop generating after a fixed number of tokens. The downside is that the output is likely to be cut off mid-sentence. Another method is to use stop tokens or stop words. For example, you can ask a model to stop generating when it encounters the end of a sentence token. Stopping conditions are helpful to keep latency and costs down. The downside of early stopping is that if you want models to generate outputs in a certain format, premature stopping can cause outputs to be malformatted. For example, if you ask the model to generate JSON, early stopping can cause the output JSON to be missing things like closing brackets, making the generated JSON hard to parse. Test time compute. The last section discussed how a model might sample the next token. This section discusses how a model might sample the whole output. One simple way to improve a model's response quality is test time compute. Instead of generating only one response per query, you generate multiple responses to increase the chance of good responses. One way to do test time compute is the best of n technique discussed earlier in this chapter. You randomly generate multiple outputs and pick one that works best. However, you can also be more strategic about how to generate multiple outputs. For example, instead of generating all outputs independently, which might include many less promising candidates, you can use beam search to generate a fixed number of most promising candidates, the beam, at each step of sequence generation. A simple strategy to increase the effectiveness of test time compute is to increase the diversity of the outputs. Because a more diverse set of options is more likely to yield better candidates, uh, well, that is why you would, yeah. So a simple strategy to increase the effectiveness of test time compute is to increase the diversity of the outputs. This is because a more diverse set of options is more likely to yield better candidates. If you use the same model to generate different options, it's often a good practice to vary the model's sampling variables to diversify its outputs. Although you can usually expect some model performance improvement by sampling multiple outputs, it's expensive. On average, generating two outputs costs approximately twice as much as generating one. Warning, I use the term test time compute to be consistent with the existing literature, even though several early reviewers protested that this term is confusing. I mean, it's all going to be confusing. The term temperature was used, which is very confusing. In AI research, test time is typically used to refer to inference because researchers mostly only do inference to test a model. However, this technique can be applied to models in production in general. It's test time compute because the number of outputs you can sample is determined by how much compute you can allocate to each inference call. To pick the best output, you can either show users multiple outputs and let them choose the one that works best for them, or you can devise a method to select the best one. One selection method is to pick the output with the highest probability. A language model's output is a sequence of tokens, and each token has a probability computed by the model. The probability of an output is the product of the probabilities of all tokens in the output. Consider the sequence of tokens I, comma, love, comma, food. If the probability for I is 0.2, the probability for love given I is 0.1, and the probability for food given I and love is 0.3. The sequence's probability is zero point 0.2 times zero point 0.1 times zero point 0.3 equals 0.006. Mathematically, this can be denoted as possible. The probability of I love food of those three words showing up one after another equals the probability of the word I showing up multiplied by the probability of the sequence I love showing up, or the sequence of love being the next word, times the probability of uh, wait, that's confusing. That notation is very confusing. So times the probability of food and then the pipe character I comma love. Huh. Well, let's get a clarification of that order from the ChatGPT because maybe that's a typo. I'm not sure why it shows up like that. Okay, and then let's see. So for casual everyday book conversations without heavy analysis, 3.5 is the most efficient. Oh, and you know what? Its own training data is out of date. It doesn't even know the latest about itself because its training data is out of date. Oh, you know what? It got it wrong. Sorry, I mean models O1 versus models O1 versus 4.0. All right, let's see what it says about that. And I mean, already it's so slow. Like, screw it, I'll just use the faster one. Okay, yeah, it's completely not giving the right answer, anyways. All right, so there we go. So review the equation for accuracy. Specifically, tell me if the order of the input to the letter P, like the left and the right hand side of the pipe character, is that correct as written, or is there a typo there? Okay, it appears to be correct. The order of inputs. Okay. All right. So let's ask it a follow-up question here. Okay, so why is the second instance of the letter P with open close parentheses, why is the word love on the left and the word I? Oh, wait, I think I get it now. Oh, no, you changed it. Look at the original text. You switched it around. Uh yeah, you switched it around. If you look at the original text, you can see that the second instance of P, it looks like there's a typo. Do you see it? Yeah, doesn't match. Yeah, it's because the new word should be on the left. Okay, so should the new word be on the left or the right? Because I can't tell. Sorry, there are some typos, but it should be clear what I'm saying. Should the new word be on the left, L-E-F-T, or should it be on the right? Because I can't tell if the instance of that letter P and the inputs given to it is what has the typo, or if the typo is in the third instance. All right, now it's going very slow. So, okay, so we got to know the chain rule of probability to know for sure. So, it should be on the left. Yeah, because it's a conditional probability of the word love occurring after I. So if you had I on the left and love on the right, it'd be the conditional probability of the word I appearing after the word love. So it's the probability of something occurring after something else. So you have to write the something on the left and then the occurring after this, you write that on the right. So we can see there's a big fat typo in here. It's the second term in this equation. P I that is flipped. That needs to be the other way. So this is big and fat enough to send to the author because this is really bad. So she didn't respond to my last one, which is fine, but I've just contacted her on LinkedIn because we'll see if she accepted my uh, connect request. If she didn't, I might not be able to send her a message. There was no information for how to contact her, so I don't know how she wants errata to be submitted. Oh, you know what? Here's another message. Nope, so I can't cold message her. She didn't accept my connect request. So I can't submit further errata for this book. So if you're reading it, just be aware. You should have enough sense of what the equation means anyway to be able to look at the typo. I did, and so probably have a bit more of a sense than I do if you're reading this. So the second term here is a typo. These should be flipped. So small, easy to correct, easy to see typo. Remember that it's easy to work with probabilities on a log scale. The logarithm of a product is equal to a sum of logarithms. So the log prob of a sequence of tokens is the sum of the log prob of all tokens in the sequence. So log prob of, now let's see if there's typos here. Yeah, there's another typo. So the middle term still has a typo, unfortunately. So log prob of I love food is equal to the log prob of I, and the log prob of uh, the letter I occurring after the word I occurring after the word love, which is a typo. We need to see the probability of the word love occurring after the word I. So easy fix, just put that in your mind there. Um, Submit the errata if you can. I didn't figure out how to, so just moving on. And then the final term is has it right. It's the probability of food occurring after the words I and the words love. With summing, longer sequences are likely to have a lower total log prob. Log prob values are usually negative because log of values between 0 and 1 is negative. To avoid biasing short sequences, you can use the average log prob by dividing the sum of sequences by its length. After sampling multiple outputs, you pick the one with the highest average log prob. As of this writing, this is what the OpenAI API uses, which is probably different now. Let me advance the bookmark and check that citation. It looks like okay, there we go. So bookmarks, delete the old one, hide it, check that citation. It's number 30. So as of this writing in the OpenAI API, you can set the parameter best of to a specific value, say 10, to ask OpenAI models to return the output with the highest average log prob out of 10 different outputs. Okay, so this is a special way you can configure um, the API to respond. And one thing I think is easy to kind of get wrong about how ChatGPT works is if we pull up the OpenAI, the ChatGPT frequently asked questions. Yeah, so here we go. OpenAI Help Center, frequently asked questions. It should be so. I know I've seen this before somewhere. Uh, it's about the. I think it would be in the pricing section. So I could probably do a control F for that. Pricing, billing, stuff like that. There we go. So what is ChatGPT Plus? So it should say it. Yeah, so here it is right here. I'm using the free subscription of ChatGPT. So does that mean I can use the ChatGPT API tool for free as well? No, API usage is its own separate cost. And then related to that is ChatGPT API, and so I'm paying for it. I'm paying a lot for it. So do I get to use the API as well? And that's something a lot of people were curious about, and that's something that would convince a lot of people either to get that subscription or not. But the answer is no. The ChatGPT API and ChatGPT Plus subscription are billed separately. The API has its own pricing, which can be found here. The ChatGPT Plus subscription and it looks like this is out of date. They did not update their pricing for ChatGPT Plus. We can see the pricing here for the pro version of ChatGPT Plus. It's $200 a month. For the enterprise version, you have to contact sales, and it's more than you can afford. Uh, but what do you get for the enterprise version? Um, you get speed. Speed's always nice. You get a higher context window, which is nice. Oh, well, you actually get the same context window for Pro. Uh, wow. Okay, actually seem to get less features with Enterprise than you do with Pro. It looks like you get, huh? That's that's interesting. Oh, here's the main features you get with Enterprise that you don't get with Pro. Security and administration. So I don't know what that means. This is the pricing for Chat GPT, which is a different product from the OpenAI API. So if we come here and we look at pricing, the pricing is completely different. You pay per the API call rather than buying a subscription. It's a whole different pricing model because they're whole different separate products. All right, so let's flip back over to that bookmark. With summing, longer sequences are likely to have a total log prob. Log prob values are usually negative. Oh, I think I read that already. Yeah, okay, I was at citation 30. Another selection method is to use a reward model to score each output, as discussed in the previous section. Recall that both Stitch Fix and Grab pick the outputs given by high scores by their reward models or verifiers. Nextdoor found that using a reward model was a key factor to improving their application's performance. They found that in 2023. OpenAI also trained verifiers to help their models pick the best solutions to math problems. They found that using a verifier significantly boosted the model performance. In fact, the use of verifiers resulted in approximately the same performance boost as a 30x model size increase. This means that a 100 million parameter model that uses a verifier can perform on par with a 3 billion parameter model that doesn't use a verifier. All right, I am back here. So DeepMind further proves the value of test time compute, arguing that scaling test time compute, for example, allocating more compute to generate more outputs during inference, can be more efficient than scaling model parameters. The same paper asks an interesting question. If an LLM is allowed to use a fixed but non-trivial amount of inference time compute, how much can it improve its performance on a challenging prompt? In OpenAI's experiment, sampling more outputs led to better performance, but only up to a certain point. In this experiment, that point was 400 outputs. Beyond this point, performance decreases, as shown in figure 2-19. They hypothesized that as the number of sampled outputs increases, the chance of finding adversarial outputs that can fool the verifier also increases. However, a Stanford experiment showed a different conclusion. Monkey Business finds the name of the experiment in 2024 finds that the number of problems solved often increases log linearly as the number of samples increases from 1 to 10,000. While it's interesting to think about whether test time compute can be scaled indefinitely, I don't believe anyone in production samples 400 to 10,000 different outputs for each input. The cost would be astronomical. All right, so here is figure 2-19. OpenAI in 2021 found that sampling more outputs led to better performance, but only by up to 400 outputs. You can also use application-specific heuristics to select the best response. For example, if your application benefits from shorter responses, you can pick the shortest candidate. If your application converts natural language to SQL queries, you can get the model to keep on generating outputs until it generates a valid SQL query. One particularly interesting application of test time compute is to overcome the latency challenge. For some queries, especially chain of thought queries, a model might take a long time to complete the response. Kittypat Compe, head of AI at Tiffin, told me that his team asks their model to generate multiple responses in parallel and show the user the first response that is completed and valid. Picking out the most common output among a set of outputs can be especially useful for tasks that expect exact answers. For example, given a math problem, the model can solve it multiple times and pick the most frequent answer as its final solution. Similarly, for a multiple choice question, a model can pick the most frequent output option. This is what Google did when evaluating Gemini on the MMLU benchmark. They sampled 32 outputs for each question. This allowed the model to achieve a higher score than what it would have achieved with only one output per question. A model is considered robust if it doesn't dramatically change its outputs with small variations in the input. This the less robust a model is, the more you can benefit from sampling multiple outputs. For one project, we used AI to extract certain information from an image of the product. We found that for the same image, our model could read the information only half of the time. For the other half, the model said the image was too blurry or the text was too small to read. However, by trying 3 times with each image, the model was able to extract the correct information for most images. All right, and I think I'm gonna just do a short one here. So I'm gonna stop here, and next video we'll start with structured outputs.